My dear students, very good morning. I am Satya Narayanan, your chemistry teacher. Today, we are going to learn the topic called Postulates of Modern Atomic Theory from the lesson Atoms and Molecules. So, let us go for some basics. We know that every matter in the world is made up of atoms. Let's go for the pencil, pen, the things we see around us. Everything is matter, so which is made up of atoms. So the fundamental particle of matter is an atom. We cannot see the atom through our naked eye. That means the atom is very small particle. Hence we can conclude atom is the smallest particle. Up to 18th century, the scientists believed that atom was considered as indivisible particle. In fact, the word atom comes from the word atomas, which is a Latin word meaning incapability, incapability of being cut. That means it is an indivisible particle. That is a fundamental particle of a matter, they said. But you have studied in your ninth standard that the atom can be divided further. They have found out the subatomic particles called electrons, protons and neutrons in it. So after the discovery of electron by J.J. Thomson through cathode ray tube, proton by Goldstein and neutrons by James Chadwick, the atom is divisible now. So atom is considered to be a divisible particle now. In other words, the atom is no longer indivisible. Let us come to the next point. So this topic also we have studied in 9th standard. Here, the word isotopes. Let us go for the meaning of this word. The word the iso means similar. Come to the next letter T. The T, we can remember this. The T indicates the top number is different. The top number is different. Okay, then we will understand with an example. Before we go into the topic, we should know the representation of an atom so that it will be very easy. So generally the atom is represented by X. It's a symbol of an element, symbol of an atom of an element. Z is an atomic number which is either the number of proton or the number of electron in the neutral atom. A is a mass number which is a sum of number of protons and number of neutrons present in the nucleus of an atom. So compare this structure with this. 17 is the bottom number, so which is an atomic number of Cl. Cl is the symbol of chlorine atom. 35 is the top number, is a mass number of chlorine. Similarly, the chlorine element has two isotopes. One is 17 chlorine 35, another one is 17 chlorine 37. 17 is atomic number, Cl is a symbol, 37 is the mass number. So this is the basics. So let us go for the concept. (17 chlorine 35 and 17 chlorine 37). Compare these two atoms. Both are chlorine atoms. That means both the atoms are chlorine. That means these are the atom of same element having same atomic number but differ in their mass numbers. The mass number is different, otherwise called atomic mass. So what we can conclude from this statement, from this concept, we can conclude that atom of a same element may have different atomic masses. Even though the atom of same element may have different atomic masses. Come to the next point. Isobars. Similarly, what do you mean by iso? As I said earlier, which means similar. Next, take the letter B. It's a bottom number is different. Which is bottom number? You're right. Atomic number is the bottom number. Let's go for the example of isobars. So 18 argon 40, 20 calcium 40. 18 is an atomic number of argon. Ar is an symbol of argon. 40 is the mass number of argon. 20 is the atomic number of calcium. 20 calcium 40. Just focus this. These are the atom of different elements. This is argon, this is calcium. Look at the bottom number. The atomic number is different in both the cases. What about the mass number? The mass number is similar. Even though the atom of different elements, they do have some property same. So what we have concluded from this, atom of different elements may have same atomic masses. I hope you have understood this clearly. Come to the next one. This is a very important point. I have taken an equation from your physics portion. The topic is nuclear fission. 92 uranium 235 is an radioactive isotope of uranium, is bombarded with slow moving neutrons. The resulting atom will be 92 uranium 236, which is unstable because the nucleus is very heavy. So it automatically splits into barium and krypton. 56 barium 140 plus 36 krypton 93 plus 3 neutrons along with 200 million electron volts. Such a huge energy is released in this process. So what we have learned from this equation? So far, one atom cannot be converted into another atom. But what this equation says? Carefully if you watch, the uranium atom is converted into barium and krypton. So one atom of an element can be converted into another atom of element. In this case, uranium is converted into barium and krypton. So what is the conclusion we are going to give from this? Atom of one element can be transmuted, that means transformed into atoms of other elements. This process is called artificial transmutation. What is one more point this equation says? Atom is destructible. It can be destroyed. The uranium is destroyed to form a new elements. So what is the other point we have to focus? The atoms of one element can be destroyed to form new elements. That means atom is no longer indestructible. Let us move on to the next important point. Ratio of atoms in a molecule. We all know very well H2O. It is a water molecule. The atomic ratio between the hydrogen and oxygen. What is meant by this atomic ratio? The number of atoms of hydrogen and number of atoms of oxygen. If you take a ratio between that, we call atomic ratio. So how many number of hydrogen you see here? 2. So the 2. The atomic ratio of oxygen is 1. So the atomic ratio between hydrogen and oxygen in water molecule is 2:1, which is a simple ratio. Come to the next example. Carbon dioxide molecule. The ratio of carbon and oxygen is 1 is to 2. It means the number of carbon here is 1 and oxygen is 2. So the atomic ratio of carbon and oxygen is 1 is to 2, which is a simple ratio. It is a simple ratio. Come to third example, glucose molecule. The formula is C6H12O6. The atomic ratio of carbon, hydrogen and oxygen is 6 is to 12 is to 6. Is there any common number to divide? Yes, you're right. Of course, the common number is 6. So if you simplify this, we will get it 1 is to 2 is to 1, which is also a simple ratio. Come to the next example, sucrose molecule. The formula is C12H22O11. The ratio is 12 is to 22 is to 11. Just think, is there any common number to divide? 12 and 22 can be divided by 2, but 11 we cannot. 11 and 22 we can divide by 11, but 12 we cannot. So there is no common number, so that the ratio is 12 is to 22 is to 11. Definitely this is not a simple ratio. So the first three examples have simple ratios, whereas the fourth one has a complex ratio, or else it's not a simple ratio. So what is the conclusion we are having from this statement? Atom in a molecule may not always combine in a simple whole number ratio. Atoms in a molecule may not always combine in a simple whole number ratio. That may be a complex ratio. If you take our DNA, RNA, amino acids, the ratio is very, very complex. It's not a simple ratio. Let's come to the next point. Now to understand that, I'm going to focus on the nuclear fission reaction. Look at this reaction. Uranium 92-235 is bombarded with slow moving neutrons. In another reaction, is split into molybdenum and lanthanum along with 2 neutrons and 7 electrons. We have studied that the mass of reactants is equal to the mass of products. That's what the law of conservation of mass says. During a chemical change, the mass is conserved. That means when I add these two masses, when I compare with this mass, it should be very, very equal. But look at this reaction. So the mass of uranium 235 is this, neutron is this, and molybdenum they have given, lanthanum also they have given. So if you calculate that, 235.118 plus 1.009, so that comes around 236.127. Similarly, for the molybdenum 94.936 plus for the lanthanum is 138.95 plus we have 2 neutrons, 2 into 1.009. The electrons have negligible mass, so the mass is 0. After adding all these things, what is the masses we have got? 236.127, 235.906. Do you think the mass is similar? This equation is against the law of conservation of mass. That means, when you compare the masses, the mass of reactants is in higher side, the mass of product is in lesser side. Some mass have gone. where it has gone. It's what? The mass is converted into energy. So the sum of the mass of an reactance can be converted into energy. So the difference is 0.213. So if you multiply with the 131 million electron volts, it's equal to 1 AMU. So you will get around 200 million electron volts. That's what I've said earlier. So 200 million electron, such a huge energy is released from one uranium atom. Some of the mass is converted into energy. Okay, let's go to the concept. The conclusion is the nuclear reaction, the mass of an atom is converted into energy as per the Einstein equation E is equal to mc squared, where c is the velocity of light, which is a very constant number. So we can write this equation into E is directly proportional to m, or m is directly proportional to E, which says the mass of an atom can be converted into energy. Let's go for the last point, that is atoms take part in the chemical reaction. Let's go for the reaction. Hydrogen molecule, chlorine molecule, which gives hydrogen chloride. So H2 is a hydrogen, Cl2, which gives 2Cl, 2HCl. Here, the covalent bond between the hydrogen breaks. Similarly, the covalent bond between the chlorine breaks. So when they colloid each other, because these two are gases. So when they colloid with this, the old bonds are breaking like this, and the new covalence bonds are forming like this. So we have got two HCl molecules like this. So this bond is breaking and this is newly made. So we got that. So which takes part in the chemical reactions? Atoms takes part in the chemical reaction. Okay, I hope we have learned that basics. Let us go for the points in your book. Look at the first point. Atom is no longer indivisible after the discovery of electron, proton and neutrons. Atoms of the same element may have different atomic masses. So as I said, 17 chlorine 35 and 17 chlorine 37. The mass is different. Atom of different element may have same atomic masses, 18 argon 40 and 20 calcium 40. Atom of one element can be transmuted into atom of other elements. This process is called artificial transmutation. That means atom is no longer indestructible. Atom may not always combine in simple whole number ratio. The ratio of glucose is 1:2:1, whereas sucrose is 12:22:11. It's not a simple ratio. Atom is the smallest particle that take part in chemical reaction. The mass of an atom can be converted into energy. E is equal to mc squared. My dear students, I hope you have learned this topic clearly. If you have any doubts, you can send it through WhatsApp or my email ID. Thank you so much. I will send you the assignments and worksheet for this little later. Thank you.